poco de luz sobre eso. Entonces, directamente les dejo paso a ellos y, bueno, espero que lo disfrutéis. Y saludo también a la gente que nos está siguiendo por streaming.
Gracias, Israel. Hola, ¿qué tal? Buenas tardes. Ante todo, muchas gracias por venir. Nos alegramos de que haya suscitado interés en la comunidad. Muchas gracias a Hackademy, muchas gracias a la comunidad de Node.js por facilitarnos esta charla. La idea es que vamos a hablar de nuestra experiencia con Microservices. Es una arquitectura relativamente nueva. Efectivamente es muy hype, mucha gente habla de ello. En Londres, por lo menos, es una palabra muy trendy que realmente poca gente ha probado en producción. Entonces, nosotros no venimos a sentar cátedras, simplemente venimos a contaros una historia, la historia de cómo migramos una plataforma escrita inicialmente en .NET a Node.js con Microservices. Tenemos un hashtag de Twitter, Killing Legacy, porque ese es nuestro propósito. Somos asesinos de código antiguo, inútil y mantenible. Vamos a estar posteando las ideas que nos parecen interesantes. Nos gustaría que a quien le apetezca pues que también lance sus preguntas, pensamientos. Y posteriormente vamos a tener una charla informal para quien quiera unirse en un bar, aquí en un par de calles, cerquita. Estaremos ahí a la entrada para quien nos quiera seguir y podamos hablar de manera más informal y quizás podáis hacer preguntas más directas. Al final de la charla vamos a tener una ronda de preguntas. No os preocupéis si no queréis hablar en inglés, podéis hacer las preguntas en español perfectamente y bueno, tanto Steve como yo podremos contestarlas. So I don't want to delay anything, a bit more the talk. So I'm going to introduce Steve Creswell to all of you guys. He's going to start giving the talk for you, and I hope you enjoy it. And see you later.
Hello. My name's Steve Creswell. I'm the co-founder of a software consultancy called GuideSmiths, and for the last 3 or so years, we've been decomposing, destructuring, killing legacy systems using microservices and Node.js. And I've noticed that there's an awful lot of technology change in this space, a lot of tools coming out. But the thing also is that the principles and the architecture of how you decompose these systems, that's not going to change. So I wanted to talk about it. We have, jump forward, we have a client called Tez. We've been working for Tez for 2 years. And we've been taking apart, as possibly Felipe told you, some legacy systems for them written in .NET. Tez started life over 100 years ago as the Times Education Supplement. It was a newspaper insert into the Times newspaper. And they've been supporting the education system all that time. Now they are the largest teaching website in the UK. They have 8 million users. They have a teaching resources platform, a marketplace where you can buy, you can sell, you can share for free teaching material. And that site gets up to 1 million downloads each day. But I'm going to talk about a different system, their jobs platform. Now, the Tez jobs platform is what makes everything else at Tez possible. It's their main revenue earner. It has 120,000 searches, I think, each hour, 400 job views a minute, 1,000 new jobs added each week at peak. And the big figure, the important figure, is the £90 million turnover. That's partially, it's majority online, but also print. But this system has some big problems. Which we'll go into. So if you looked at it prior to January this year, this is what you would have seen. You could search for jobs, you could browse for jobs, you could view a job, you could view an employer, you could apply for a job, you could manage your saved searches, your favorites, and your applications. and you could subscribe to job alerts, daily or weekly. Now, as you can see, the user interface wasn't modern. It wasn't responsive. You couldn't see that, but it looked terrible on a mobile device. The technology, it was .NET-based, SQL Server, autonomy for search. It was deployed to a co-located data center with fairly old equipment with very poor visibility. And about 2 years ago, Tez acquired a CTO, a very forward-thinking CTO, who understands the value of the cloud and loves Node.js. So the tech was no longer strategic. It was expensive to maintain. You have license fees for all these products. But more than that, the software was inefficient and slow and had to be run on multiple servers. The support teams, you needed dedicated DBAs and system admins to support it. So it wasn't cost effective to run. And lastly, it wasn't easy to change either. They had a 3-month change release cycle, partially due to fear of breaking things. And that was because this monolithic application had no unit tests, no tests of any sort. It had no automated deployment, let alone continuous deployment. So they were in a very, very bad shape. And that's when we came in. So we'd been working on this resources platform, and the initial plan was to get us to help with the integration of their rebuild. And they wanted to take the job booking system, which was written by a third party, it was a product, and move that into Salesforce. The jobs booking system was called AdTaker by a company called MSL. It had been designed for print. Parts of it were written in Smalltalk, parts of it in .NET version 1. And they wanted to take that and, as I said, port it across. They selected a partner for doing the user interface, a company called Magix, who had a hosted jobs board. And our job was to take the messages, the employers, if you have jobs, you always have employers, to take the employers and the jobs emitted from Salesforce and split them over to, send them over to Magix and send them over to the print system, and also to integrate with the accounting software for the finance. But that project failed. It turned out that the booking system, the discount model, the product catalog was too complicated for the team to implement in Salesforce. And so they canned it after about 4 months. Instead, they came back and said, right, we're going to have another go at this. We're going to leave the booking system where it was because that was the really difficult part. They're going to keep the employers in Salesforce because that had already been migrated. They abandoned Magix and wanted to build their own UI, and again asked us to do the integration and to lead the team doing the user interface. But the catch. So I said in the description of this talk that we rewrote this system in 9.5 months, but we only had 4.5 months at this stage. Teaching is a seasonal business. Teachers change jobs at the end of the holidays, so summer, Christmas, Easter. And the board had promised to Tez's parent company that by Christmas they would have a mobile-friendly platform with some new mobile-specific products, and their budgets had been done by that. So we had to take this system and redo it in 4.5 months. This is the architecture. So you book jobs. The product's called AdTaker, but internally at Tez it's called MSL, so I left it as that. They are emitted via MSMQ as big XML blobs over to the Jobs app. They were stored in SQL Server using some horrendously complicated stored procedures, and the outcome of that was, along with other things, a friendly job ID. They were indexed in autonomy, served via IIS, through Fastly to the end user. Jobs can have attachments, school prospectuses. They were uploaded into MSL, and they were robo-copied across to a file system, served via IIS, again, to the end user. Now, when we took this system and looked at it, I wanted to try and remember or write down and share some principles to the approach that we took. And the first principle I used was we wanted to keep the old system running. By keeping the old system running, it meant that if we didn't manage to deliver the new system in 4.5 months, they had a fallback strategy. All right, they'd have to explain to the parent company why they didn't have their mobile-first jobs platform with the new products, but it's an awful lot better than losing a £90 million business just before peak. The other thing is that if we had switched over to the new system and started booking new jobs in it, if we hadn't kept the old system running, accepting those jobs, then we couldn't have switched back without some kind of horrible reverse migration. So it was really important to keep it running. The second reason for keeping it running is because it enabled us to cherry pick which parts of the system we migrated over and when. So in order to get a mobile-first site with these new products, we didn't have to migrate everything. We needed the jobs details page, the employer page, and we did search. We didn't need to do applications, and we didn't need to do save search with the email alerts, so we left those till later. A third reason for keeping it running is because we could reconcile. So with the old jobs still going through to the old system, and the new and the jobs coming through to the new system in parallel, we could write a tool to automatically compare both. And this would tell us when we got it wrong. One of the principles that I think is really important with a system like this is you have to get the data very, very early. We made the mistake on this previous resources project of not doing that. It wasn't really in our control, but we should have done more. And it took 3 months to get the data with that system. And that was 3 months of development time based on assumptions that turned out to be wrong. So we didn't make the same mistake with the job system. We got the data from the logs on the very first day we started the project with these XML messages, and we put in a feed within a week that started to get live jobs coming over to Nginx within a week. And we had help. The other critical success factor to this project is that we weren't an external coming in. We worked with the best guy from the old project who knew the system, who knew the connections, who knew the people, who understood how it worked and could help us get access. So we had an inside man. So with all that in mind, the first service we developed was what we call the splitter service. It was a .NET component that intercepted these XML messages and forwarded them to a new recipient in AWS and relayed them on to the old system. We needed to modify the old system to get the job IDs, because in order to parallel run and to do this cherry pick approach, we needed to have the same IDs that were generated by the stored procedure. And we needed to download the file attachments from IIS. Then, as pages came online on the new system, via Fastly, we would put in a rule to serve the page from the new system rather than the old. And initially, we did this with secret query parameters, and so the majority of our demos we did in live using a query parameter that was known to us. And then later, we put in place a beta program where users could opt in and it dropped a cookie, and that's what Fastly used to route you to the new site. In AWS, we received the job messages via HTTP into Nginx, and we got the employers using the same route from Salesforce. But the first thing we did with them was receive them or take that into a microservice which acted like a protocol converter, and it translated the HTTP message into MQP and set it onto a RabbitMQ messaging bus. One or more microservices would consume the message, at some point download the job ID and the files, store them in Mongo and S3, and then when a user requested a page, a front-end microservice would receive that request and serve the page through Nginx, out through Fastly. So that MQP, or that HTTP to MQP converter, this is actually, out of the lot, my favorite service. And what it does, it takes a post request to a URL, and goes off to etcd and downloads a schema if it hasn't got it in its cache, validates the message. If it fails basic validation, it will return a 400. Then it converts the URL into a routing key, and publishes it to Rabbit. Now, any service with a compatible key will receive a copy of this message. And the reason why I like this service so much is because there is no business functionality anywhere near it. It's simply taking a message from one protocol and publishing it using another. And because of that, we never have to change it. We use etc.d, so the config is dynamic. It will update itself when a schema changes or if we need to add in a new route. And so with the Salesforce message, the only difference was the URL, the authentication credentials, the schema, and a new routing key was generated. And this comes back to some of the other principles of microservice development, that they should do one thing well. If you do one thing well and they contain no business logic, then there's no reason for them to change. The other reasons I like this service is because I like HTTP. It's a simple protocol. If you think about what we were doing, these AWS and the old data center in different countries on completely different networks with firewalls and VPNs between them. And although we could have done, if we would have tried to publish the message directly to RabbitMQ, we would have had to ensure that across this data center, which was old, that message got there. And a different project, the registration project, had tried to do this, and it was problematic. The next reason I wanted to use HTTP for the front door is because we didn't know what the Salesforce developers were going to be like. And working with RabbitMQ requires a degree of complexity and experience. But pretty much anybody can send an HTTP request. And so it kept it simple for the third parties that were beyond our control. Security is very, very simple. With RabbitMQ, we would have to have been concerned on whether you could publish a message with the wrong routing key, potentially subscribe to messages. We might have had to set up a different vhost, all sorts of things. But everybody understands HTTP security. It's HTTPS, and then you pick your authentication method. So that made things very, very simple and very, very easy. When the third-party developers had trouble sending in an HTTP request, I could send them a one-line curl snippet and say, look, run this. If this works, the problem's not at our end, it's at your end. So that was why we chose HTTP for the front door. But I also like messaging. Messaging has some really strong advantages. So one thing is that HTTP is point-to-point, whereas messaging, multiple services could consume the same message. Another reason for using messaging is because provided you're sensible in your choice of platform, then you get high availability built in for free. Now, the HTTP to MQP adapter doesn't get redeployed. It's behind load balancers. We don't change it. So I was less worried about that service, but our business services, we want to deploy whenever business rules change, and our front-end services, we want to deploy whenever we want to change the user interface. And so by using RabbitMQ to decouple the publishers of the messages and the subscribers meant that we had far less to worry about from a resilience point of view. And I didn't want these job messages going missing and to have to find out how to resend them and all those sorts of things. So that was another advantage we got from the messaging platform. With messaging, you can get a certain amount of recoverability provided. So RabbitMQ has the concept of dead letters, transactions, and rollbacks. And so if a service had a problem processing a message, it could roll the message back and retry. And we built some tooling around Rabbit that lets you instead publish a message to a delay queue, and it would then retry automatically in 5 minutes' time. And that was important for our system because there was no guarantee that the message wouldn't be stored or would be stored in the SQL Server database and available before we had received it and processed it. And so it's possible that we would be requesting those job IDs before the job ID actually existed. And with this service, with this facility, we would retry the message up to 10 times at 5-minute intervals. If it still failed, then it would be dead lettered, and we monitor the dead letter queue, and we get text messages whenever that happens. So it meant that we didn't have to worry too much about supporting administrant in the system because the majority of errors will recover naturally. But there are problems with messages that you need to be aware of, and you actually get this with HTTP as well, but in our scenario, it was something that we really had to think hard about. Because we had this retry strategy, we had no guarantee that we would consume messages in the same order that they had been sent. Rabbit does offer you a guarantee that if you push a message to a queue, it will be consumed in the same order. But we have multiple instances of each service running. And so even if the messages were queued in the correct order, we couldn't guarantee that we would process them in the same order. And if a message failed and we put it onto our 5-minute delay queue, there's absolutely no guarantee at all that when it came back, it would still be the freshest message. And so the way we handled this, at each message in our system, we ensured it had an explicit version number, and we ensured that any system consuming those messages would at least do a version check before persisting it or operating on it. So after the HTTP to MQB adapter, we've published a jobs message to Rabbit, and our next service, the MSL adapter, would receive that message and store it in Mongo. And it would do minimal transformation logic. It was the main payload of the message was XML, and all we did was convert it to JSON and actually store the original. We decorated it with the original XML message and stored it in Mongo. And then we published an event that says, hey, I've just saved a job. Now that same service received the message that it just admitted, read the document back from Mongo, cross-referenced it with ref data, and performed a whole load of transformations on it to clean it up, and published an event that say, hey, this job has been transformed. So the job of this service was to decontaminate. Because when you have a legacy system like MSL that had been designed for print, that was operating on a completely different ref data model than the rest of the ref data at TES, you don't want any of those legacy decisions, those hacks, those workarounds that have been built up for the 10 years that system might have been running to infect the new code that you're writing. You want to take the best version of a job that you can at that point. And so whenever we interact with a legacy system, we always build in a decontamination layer that makes the message clean from downstream. Now, this service was complicated, it was ugly, it certainly doesn't fit any of the rules that you might have heard about how big a microservice should be. That wasn't in our control because the transformation logic was very, very complicated. But everything downstream from that could be simple. Now, the reason for the two-step approach, the simple transformation and persistence, and then the more intensive transformation and publish, was because we knew we were going to make mistakes. We had to plan to fail. Now, with code or with transformation logic this complex in a system that you're not familiar with, you can't help but make mistakes. So we needed a system where we could recover from those mistakes by rerunning the same jobs through better transformation logic and emitting the new messages downstream. There was no way to do this from MSL. You couldn't replay a batch worth of jobs. We would have had to gone up to the booking team and said, look, really sorry guys, we screwed up yet again. I know you've been busy, you've been booking 200 jobs today, but can you go and rebook the 1,000 jobs from last week? That just wouldn't have been acceptable. So that's why we did this two-step approach. And it came in very, very handy. We screwed up once with ID uniqueness, but we recovered. After we went live, the Salesforce guys made a mistake and they ended up managing to corrupt the latitude and longitude for every employer, the 80,000 employers in the TES database. And for 2 hours, jobs were booked instead of to their correct locations, but they were booked to the middle of the English Channel. This meant that searches didn't work, and it meant that when you looked at the jobs map, it was just blue. When they fixed their code and republished those 80,000 employers, we just ran a Mongo query that said, find all the jobs that have been booked in the last 2 hours and replay them, and the system recovered. So the next service in the chain was the jobs API. And this guy receives those clean transform messages from the MSL adapter, fetches the job ID, and persists them in Mongo. No transformation required because the messages are already clean. But this service is interesting because this is where we broke the rules. Sorry, it also publishes a message. And you can see that the message has a dynamic routing key based on the status of the job. But yes, this is the service where we broke the rules. This service doesn't do one thing, it does two things. It also receives the employer messages from Salesforce, persists them to Mongo, and publishes an event. The reason we broke the rules is because in our model, you never have a job without employers. You always want to surface them at the same time. And you never have employers without jobs. The alternative would have been to have two separate services, both following a very, very similar workflow, persisting employers, persisting jobs, providing an API to retrieve them again. And then when somebody requested a job, we would get that first, and then we'd have to make a request to the employer service and get the job's employer, and vice versa. And so one of the patterns that I try to avoid, or at least I try to keep an eye on, we don't avoid it completely, is this idea of HTTP chains. So REST and HTTP, they're lovely protocols, they're really good principles, but when you're dealing with microservices, you run the risk of building up a chain of sequential HTTP requests, and that's brittle. HTTP connections can fail, they can time out. When chained together, they can take too long. The other pattern that we tried hard to avoid was integration by database. It's possible that we could have two services persisting these things, and another set of services retrieving from Mongo to provide the APIs. But when you're dealing with microservices, you need to make sure they're decoupled. You want to be able to deploy them independently and change them independently. And so integrating by database is usually a very, very bad idea because it's difficult to synchronize changes if you do. The time that we have not followed this, there was a system that we wrote for the Mail Online that was to do with advert configuration. So the Mail have a dynamic system where, depending on the advert campaigns that are booked, their page layout will change. And so we wrote a system that sucked the adverts out of the ad server DFP, and it provided an admin interface for an operator to come along and override page configuration or set things up. And the back-end part of that system needed to be secure, and it didn't need to be highly available. The front-end part of the system for the Mail Online takes a lot of traffic, so we needed to scale that horizontally, and it needed to be public-facing. And so in that system, we separated out those two functions, and we did integrate by database. We had a Redis master replicating to multiple slaves, but the document structure was the same. And it worked very, very well in that scenario, but it's another pattern or anti-pattern that I'm very, very careful when we use. So the next service was search. We received the message that had been emitted from the jobs API. And here we do something a little bit different. We purely use that message as a trigger. We didn't use the content. And we would go and request a fresh version of the job from the jobs API, and that's what we persisted in Solr. And the reason for doing this is when we're persisting messages in Mongo, it's very, very easy to say, only go and update this job if the one already in the database is older. But with Solr, we didn't find a way to do that, and so we went and got a fresh copy of the job each time. Now, there is still a minute chance of a race condition, meaning that we persisted an old job. And if we were concerned about that, we could have put in a distributed lock using etc.d. But we took stock of the risk, and we decided it wasn't worth the extra complexity and the extra request, the extra chance that something would go wrong. It was very easy for us to re-index jobs if we wanted to, if anybody complained. And so we decided to stick with this approach. And if we found out that it wasn't working and that stale jobs were being served in search results, then we'd go and put in the distributed lock. And of course, we published a message. And you'll notice that every single one of these services that I've talked about always publishes something. And this is another useful guide in building a microservice system, that if your service isn't publishing anything useful, then possibly it's too small, possibly it doesn't deserve to exist in its own right. And the other reason that we always publish messages at the end of a workflow is because we write tests. And so we write unit tests for the steps in the workflow, but we write an end-to-end test for the entire workflow. And publishing a message at the end of the test means that you've got a hook to listen to tell you, okay, this test is finished, go and check in Solr and see whether this document got indexed. Something else that we live by on the jobs project is to pick the best data stores for the job. So Solr for search, Mongo for storing documents, S3 for files, etc. D for config and distributed locks, Redis for caching. We had a postcode database that we cached in Redis. We used Postgres initially. We didn't need it later on, so we abandoned it. But what we didn't do is have two types or two similar databases in our stack. And this is something else that I get asked a lot. If you've got lots of distributed teams working on multiple projects in microservices, how do you kind of control the infrastructure that people start to use? And I don't think you do. But the principle here is that, well, if you're using Postgres, then don't go and use MySQL, because they both do pretty much the same job. If you're using Solr, then unless you've got a really good reason, don't go and put in Elasticsearch somewhere else. And so that's the principle that we followed with our data stores. So I talked about the back-end system, but how do we do the front end? So a request would come in via Nginx, a different Nginx to the back-end interface. And in actual fact, we didn't use Nginx, we used OpenResty, which is essentially Nginx packaged with some open source modules that are useful. And Nginx would proxy the request onto a service called Page Composer. Page Composer is a service that's actually written by the CTO of the Mail Online. It's an open source project, and it acts like Varnish. It's an edge-side include. So Page Composer would send multiple requests off to other services, site assets, where we hosted our global bundles, the masthead, the footer, the navigation, and off to the jobs page service, which was responsible for serving the content of the page. Here we have one of these HTTP request chains that I said you've got to keep an eye on. It goes off and gets the data from the jobs API from Mongo, and the whole thing goes back. Page Composer composes the page fragments together. It has a Redis cache where they can be cached, and out it goes to Nginx. And the design for our front-end services was the same. So for the employer page, it's just a different request and a different React service. The search page, the same, it's just going to the search API, and the hub page going to get jobs for the hub page. There were lots of other services that we wrote that are worth talking about briefly. So one of the things that we found is occasionally these services needed to do something on a schedule that should only happen once. They wanted to be archiving data, generating reports, sending emails. And because we deploy multiple instances of each of our services, that requires some kind of coordination, whether it's election or whatever. Now, to try and put that logic in any service that needs to do this bloats the service. So instead, we wrote something called the ticker. Now, the ticker has all that logic in it. It uses etc.d for distributed locks, and it guarantees that it will publish one message every minute onto RabbitMQ. And then any other service in our stack that needs to subscribe to some kind of basic cron and ensure that something only happens once can listen to the ticker message, and it will execute its workflow without worrying whether another instance of the same service will pick up that message. We wrote something called the AMQP to S3 adapter. And this guy's job was to listen to all the messages coming in from external systems and take their routing keys and convert them to an S3 ID, an S3 key, append a date stamp, and upload them into S3. And so we have a copy of every single message that's entered our system for the last 6 months. We've set it to expire for 6 months. And that was a belt and braces approach. We could recover by replaying the jobs in Mongo, but in Mongo we only ever stored the latest version of a job. S3 we have every single version of a job ever sent to us. We wrote a jobs checker, and this guy listened to the, hey, I've saved a job message from the jobs API, and it went off and requested the old page and used Cheerio to scrape out the content, and it requested the new page, used Cheerio to scrape out the content, and reconciled the two. And what we found is that this service became our progress meter. As we understood more about the transformation logic and put in more sources of ref data, these tests started to pass. And then by the end of it, what we found was that actually the old system was the one that broken and just nobody had ever realized. We wrote a Salesforce adapter, and the reason for this is that you might know that Salesforce has API limits. And they're not so bad for normal operation, but if you're the Salesforce team and you need to fix 80,000 employers, then you need to send 80,000 employers into our system. And so they batch them up so as to not breach the API limits. None of our services want to care about batches, so the Salesforce adapter takes that batch message and splits it up and publishes them as individual messages. The URL redirection service, we use Fastly to route messages between the old and the new system, but where we had complicated URLs that we needed to programmatically decode and then re-encode into a different path, we had a service that did that. And the last service I'll talk about at the end of the presentation. The very last principle or tip I want to talk about is how we do DevOps. So this seems to be quite a big buzzword at the moment, but when I listen and I look at how some other organizations are doing it, it's obvious that they've misunderstood. So if what you're doing is you're taking an existing operations team and you're saying that this is now a DevOps team, you haven't changed anything. If what you do is you hire in contractors or build an internal team or hire in a consultancy and say, you're our DevOps team, then you're not doing DevOps. To understand what DevOps is, you have to go back to the problem that it was trying to solve. And the problem that it was trying to solve is that the interaction between a traditional or a split development team and an operations team is usually broken. And the reason it's broken is because the motivations are different. Developers are motivated to change systems. Infrastructure teams are motivated to keep them stable. And those two compete with each other. And so DevOps is about getting a single team responsible for changing and supporting a system. The other problem that DevOps was trying to solve is that when you put these in these functions in different teams, there's waste. From a lean perspective, if you've done any reading around lean, there's waste involved, there's waiting time. The developers have to wait for the infrastructure team to deploy their code. They might have to wait to get access to the systems to look at log files. And when you end up waiting for somebody else, well, if you're waiting for anything more than 3 or 4 minutes, you find something better to do. Maybe you go to lunch. Maybe you find a new part of the code base to work on. And so you find that once you start to wait, that waiting time increases and increases and increases. And the other form of waste that I saw a lot between the traditional setup was rework. Because you weren't watching when the deployment happened, if it went wrong, you come back to your desk, you find out an hour later that something was broken, you look into it, you get access to the logs finally, and then you think, oh, okay, I'll fix that. And so you fix it, and then you do another build, it goes off to the infrastructure team again, and they deploy it. And now you're on to problem 2 because that one also fails. And so you go through this slow rework cycle. And that's the other problem that a proper DevOps approach will solve. So the way TES do DevOps is that anybody with the capability who's responsible and who communicates will tell people what they're going to do or what they intend to do and what they have done can have access to any system that doesn't contain secure information. And then the people with that capability are responsible for automating things to the point where the people without the capability can use them. So at TES, we have business users making changes through the GitHub API, through editing files, who do live deployments. There's no waiting time involved. So a lot of things went right, but we did have a few things that went wrong. The first thing, and I still think we would have done it this way, but it's worth talking about. Because of the 4.5-month timescale, we made the conscious decision that the team members would specialize. We didn't work on each other's services very much. It wasn't something that we were protective of, but when you've got something as complicated as a search service with Solr, for 2 or 3 people to get involved in that code base would have taken longer, and we didn't have the time to spare. Now, the consequence that we knew that we were going to pay for this is that after we had gone live, when everybody was naturally relaxing, wanted to take some time off, some holiday, when the support issues started coming in, it would mean that we were less effective than we would have been if everybody was as familiar with the code base as each other. We knew about that, we discussed it, and it was a decision that we weren't going to do it. It was the team's decision. The next thing that went wrong was I mentioned that we had this beta program of users, and that gave us a false level of confidence. So we went live with the jobs page after about 6 weeks. And we put on this beta thing that said, if you'd like, you can see what jobs is going to look like. And we had about 5% of users opt into the beta program. But surprise, surprise, the 5% of users that opt into the beta program were not the 5% of users that were using the old browsers and the obscure mobile phones. It's a different mindset. And so when we did finally go live, we had a flurry of complaints saying, hey, I can't search. And the cause was because we'd used Flexbox, and Flexbox doesn't work well with old devices. So that was one of the things that I learned. If you're going to run a beta program, then you kind of want to push, you want to have an idea of what your devices are. And we did do cross-browser testing, just not enough of it. But that was pretty much it. Everything else seemed to go pretty well. So I'll finish with some statistics. We delivered 1 week early. We had this idea of what was our MVP to go and deliver, and we wanted to release this by the 14th of December. We carried on developing afterwards, but it was at that point that we knew that we would make it, but we delivered that on the 7th. To get there, we had 536 live releases. That's an average of 5 releases a day. And we've maintained that after going live. It's a team of 6 people. Our first live release was the splitter after a week. By dev complete, we've increased this since. We wrote 16 open source projects. The first one was Rascal, which is a wrapper around AMQP-lib. I like AMQP-lib. I think it's an excellent library. But it's hard to use, and it has some boilerplate involved. And so the things that Rascal does for you, it enables you to configure your subscriptions and your queues and your exchanges and your bindings through config. It also provides you with the facility of specifying recovery strategies, and it has this idea of, well, if something goes wrong, we're going to publish that to a delay queue. It will sit there for 5 minutes and automatically be retried. And the final thing that Rascal does for you, it has good automated testing support. One of the issues you get with messaging is it's quite easy to leave a message on a queue so that your next test fails because the message is already there, or to forget to unsubscribe from a queue, and so an earlier test suddenly fails again because it's executed some code you weren't expecting. And Rascal enables you to work around this by dynamically generating namespace queues per test run. We wrote something called GuideSmiths. Now, the idea behind GuideSmiths and the big advantage of it is that when you have 6 developers working mainly on different services independently, you want some form of consistency, and GuideSmiths gave us that. So GuideSmiths is a workflow tool, and you would receive a message from RabbitMQ into a workflow. It would execute through a series of tasks tasks are reusable components. So for example, the Rascal log at the top logs a message using a handlebars template, but because it's a Rascal log, you will always have a message ID and you always have a routing key, and it logs those with you for free. You don't have to remember to do it in a structured document. And so Worksmith gave us the idea that each of our tasks would be easily unit testable. All of the entry points to the applications would be in the same format, managed in the same way. And so even though we weren't familiar with the different services, we would always know where the entry point was. TES have a project called Electrician. It was written by one of the GuideSmiths guys, but it's their project, but it's open source. And the value of Electrician, again, is to reduce boilerplate. So when you have one of these services that reads config from etc. asynchronously, uses that config to set up a Rascal binding, connects to Mongo, and then starts Express, that's a sequence of actions that really should happen in a predefined order, so you don't start accepting requests before you've got a connection to your database. And shutdown is the same. It's the same, but in the reverse direction. And so Electrician provides a very simple way of wiring these components up so that the dependencies are understood and executed in the right order. Now, across all the projects, TES have over 100 microservices deployed. And if each one of these microservices had to do a similar sort of process, and we did it boilerplate, then it's a lot of maintenance and it's a lot of code that you've got to go and change if you want to change the startup and shutdown approach. And the last one I'm going to cover briefly is AC/DC. I mentioned that this message that we got in from the MSL system was complicated and we had to transform it. And we had to learn those transformation rules the hard way. And the code initially, when we first wrote it, was complicated, and another developer coming in 6 months after we've left would have the same problem. And so we wrote AC/DC. The idea behind AC/DC is you take an input document and you transform it to an output document safely. You don't have to worry about getting an undefined exception because some optional variable isn't there. And it does asynchronous transformations. And so if we were to look up some ref data from a database or from an endpoint, that happens in the workflow. And using AC/DC, it means that somebody can come along and instead of a bunch of code to read, they can have some fairly straightforward transformation rules. Total number of tests was 1,116. Most of these were in the MSL adapter. And that doesn't include our functional test that did a series of very, very basic Selenium tests. And for that, we used Nightwatch and a BDD tool that I wrote years ago called Yada. We got our builds down to 20 seconds. And we did this by using Docker and by using Shrinkwrap. And as Felipe says, that Shrinkwrap, it's like using a bulletproof jacket made out of barbed wire. It's a painful tool to use, but we were able to use it so that our builds would automatically cache bust if we changed a dependency, and that meant that we could cache our npm install step, and that is how we got our builds down. The fastest was 20 seconds. Most of the back-end service is around 40 seconds, and the front end, because they're doing gulp and other things and CSS stuff, would be slightly longer. And that's from code checkout to image publish. Now, I don't know the average time for our bug fix, but I wanted to talk about this as an example of why microservices are so powerful. I had a day off. I was actually working on this presentation, and I noticed that an issue had come in over GitHub. Felipe was off in Cuba, and the team was under strength. And so I got in touch and I said, hey, look, I know what this bug's about. I can fix it. I checked out the code. I ran the test to make sure they passed. I wrote a failing test. I fixed the code, ran them again, and pushed it. Made sure that it was working in our proper test environment, promoted to live, and the end-to-end time from when this bug came into GitHub to when it was fixed was 36 minutes. And that's not because I'm the world's best developer, I'm the fastest typist, or anything like that. The reason why we could turn this bug around in 36 minutes was because of microservices. If we'd have had a monolithic application, it would have taken me longer to probably find where to change, to make the change, to run the tests. It would have meant that I would have had to worry about who else had been changing the application and whether those changes were good to go live. We might have had to think about branching strategies. I might have had to get the release branch and work on that and then merge the changes back into the development branch. But because with microservices, in this case, nobody had changed the code since the last release, and we usually release a service all the way to live whenever we make changes to it, because there's no reason not to. Perhaps if we've just edited a README file, we wouldn't, but if we've made a code change, the chances are that code change will be live within a few minutes. So that's how we could fix the bug so quickly. Now, the last statistic is the one that I'm most proud of. And I said I'd talk about this service at the end. And about 4 weeks into the project, we realized we'd missed something. There was an asset manager tool that a team used to upload employer logos, pictures of happy kids running around playgrounds. And these pictures got surfaced on the employer page and on the jobs page. And we were hoping up till this point that we could get a feed to that system and just use the data and not have to do anything with it. And that assumption turned out to be false. So on top of everything else, we had to do a data migration of all the assets that they had, the descriptions, the quotes, the videos, the images, and write a new tool that the team could use to upload and resize these assets. And so when we went to find the team and see how it was, what they needed, and what we were going to build for them, we found this lady, Kate. And she is one of the most nice and enthusiastic people I've ever met. And she was suffering with this atrocious system that was click-heavy, that crashed, that meant it took 6 minutes to upload and resize an image. And this is why I like working with legacy systems, because if you work on a startup environment, the tech is great, there's no legacy, and you're building stuff that's cool. But you don't know until after you've gone live whether your time is being well spent. But when what you're doing is replacing bad legacy systems with new systems, there's already a user base. Now, in Kate's case, we liked working with her so much that she joined the team. So we got a new product owner. Thank you very much. Felipe has kindly offered to translate if there are questions, or feel free to ask.
Sure. So we're going to start the QA round with questions. So si tenéis alguna cuestión, alguna pregunta, pues disparad. Y si no, pues nos vamos al bar, ¿eh? Tampoco.
Oh, sorry.
Hello, my name is Alex. I just wondering, I have lots of questions here. So first of all, how big was your infrastructure? How many servers do you have? How big is your RabbitMQ cluster?
Sure. We typically have 3 hosts that we deploy these services to. Our deployment model is a little bit dumb. We deploy the same services to each host. We're looking at the moment at moving to something like Docker Swarm, where we can be a bit more intelligent. The Nginx servers, they're also clustered on 3 hosts. RabbitMQ is a 3-host cluster. What we tend to do is in development, we go a little bit cheaper. We might have 1 instance, and then in staging, we have 2. So we have an environment where we can test our rollout properly, and then in live, we go for 3. The servers are underutilized. They're not doing very much at all. Mongo is a 3-host cluster as well.
Okay. Did you try to deploy different services on the same server, for example?
Yeah, so all of our services are deployed and packaged as Docker images. And so on each of the jobs hosts, we will have an instance of every single node process running inside a Docker container. Those node processes use recluster, so there is actually multiple workers per container.
Okay. How do you handle logging and monitoring of the systems?
That's a good question. Logging badly. So the problem we had with logging, so a lot of this infrastructure we built on the resources project. What we did for logging is we ended up writing our own logging module, which just was a wrapper around Winston. And that published messages to Redis, and we used Redis as an intermediary queue. That turned out to be a really, really, really bad decision, because the trouble with Redis is that once it runs out of memory, you're screwed. And in this environment, when across TES we shared the logging infrastructure, any one of those, it usually takes more than one, but if there's a problem and services start to fail, and they start to log a lot, or potentially if you've crashed a service with a poison message from RabbitMQ and rolled it back, then you start to generate millions of messages to your log infrastructure very quickly. The whole lot gets backed up, and eventually Redis runs out of memory and crashes. And so the sorts of things that we've done with that, it's compounded by microservices, because one request into Nginx ends up going to Page Composer and being forwarded to multiple services, which then end up potentially going to multiple other services. And if you info log your incoming requests, you end up maybe with 20 log statements for a single inbound. And so the sorts of things we've done recently, we've reconfigured Winston to not log at the incoming request. We just use our Nginx logs for that unless there's an error. And so that's reduced our log traffic significantly. I think a better solution would be to use RabbitMQ, maybe not the same cluster for our logging, because then we have a persistent queue. And you could prioritize queues differently, so your error queue could be high priority, but your info queue could have a maximum length on it, or it could be timed out, or all sorts of things. So that's one of the other things that we're discussing doing. In terms of monitoring, so we use Datadog. Datadog's deployed on each of our servers. It's a bit like New Relic. It's a lot cheaper, and it's very, very good. We monitor our queue length, so whenever a message arrives in a dead letter queue, we get a text message. We monitor our infrastructure. Datadog lets you look historically and say, well, look, if the CPU above this box goes above 80%, then I want to start alerting for it. And we've got that hooked into PagerDuty, which is how we get our text messages.
Okay, makes sense. How do you handle authentication between the services?
Okay, so for this, we don't. So on the external endpoints for MSL and for Salesforce, sure, that's HTTPS with basic password auth. And the reason for that, again, is because we don't know the level of our third-party developers necessarily. We could go for certificates, maybe. We could do something much nicer where we take a digest of the actual content and encrypt that with a key and put that as the password, those sorts of things. But I think it would be too hard for the externals to get their head round. Internally, we don't really need to. So internally between these messages, fine, if something publishes to Rabbit, we assume that it's got permission. To get access to those systems, we use something called Black Box. So there's I think it's not necessarily a Stack Exchange project, where you have a set of scripts that will use GPG keys to encrypt secrets. We store the encrypted secrets in GitHub. And then as part of our deployment process, we decrypt those secrets and inject them into the containers. And then we merge that with the config that we get from etc.d. And so that's how each of our services gets access to the shared infrastructure.
Yeah. How do you store the source code? Do you store one service in one repo, or?
Another good question. So at the Mail Online, we had one repo for the ads project with 12 services in it. That became very, very problematic, because if you want to build a service, you've got to work out which service has changed. You don't want to be deploying all of your services in one go. And probably the most complicated part of that system was varying a series of checksums and all sorts of other nonsense, working out which services you need to deploy, and if there were modules, which modules had changed and what their dependencies were. So at TES, we took a different approach. We went for one service per repo, per project. They have about 500. They recently bust their limits. The way we manage those is via a tool called Bosco. Again, I said there's a forward-thinking CTO. He wrote a tool called Bosco that lets us check out all of our service for a GitHub team. So there's a jobs back-end team and a jobs front-end team. If you're a member of either of those teams, you say Bosco clone, it will download those, do an npm install. You can say Bosco start, it will start the services up. It will download dependencies, other services that are part of those projects, or Docker containers for a local Mongo, local RabbitMQ instance.
Cool. And what about service discovery? How services discover themselves?
Another good question. So one of the reasons that I like messaging is it solves that problem by removing it. If you only have messages that subscribe to Rabbit, then those services just need to know how to find Rabbit. You don't have to find each other. For the services which do need to talk to each other, we took the approach on the resources project 2 years ago that it was too hard, it was too new. And so we ended up giving everything a static port. We use Nginx to do our discovery. There's a wildcard DNS entry that goes to Nginx. Nginx reads config files that says, hey, if you're trying to get access to the jobs API service, it looks up and said, right, that's on one of these 3 hosts on this port, and it does our load balancing for us. That's one of the things we're considering looking at alternatives now that they're a little bit more mature, like Console or Docker. I think Vulkan D was another one as well.
Okay, that's all. Thanks a lot.
Thanks for the questions.
More questions? Now we have the cube.
I wonder if you have any experience or opinion about Zero and Q?
No, none at all. When we were at the Mail, we did evaluate multiple different queuing technologies, and that was one of them. And I believe it was, and this is 3 or 4 years ago now, so it's probably changed. It had problems at high throughput. I can't remember if it crashed or if it deadlocked, or there was some problem related to ZeroMQ that meant they abandoned it. But no, I haven't used it.
Okay, thank you.
Related with that, did you try the Amazon Q?
Yeah. Did we try Amazon Q? So SNS. So we made a decision back at the start of the resources project that we didn't necessarily want to be coupled too tightly to Amazon. And so, sure, we use EC2 instances, but they could be Rackspace or anybody else's instances. We deploy to Docker containers, but we don't use any of the Beanstalk. We don't use Beanstalk to deploy anything. We use RDSs, but that's just Postgres or MySQL. We don't use DynamoDB. We have our own Mongo cluster for the same reason. We didn't want to be coupled to it. So really, I think the only place where we're coupled to AWS is with S3. So the answer was we deliberately decided not to.
Hello.
Hey.
You talked about testing and continuous deployment. What sort of tools are you using for that? So deploying and continuously Docker images and testing?
So the question is, what tools do we use for continuous deployment and testing? So Mocha, I like Mocha. It's very simple for writing unit tests. I mentioned Yada. I didn't want to plug it too hard. That's my own BDD library. And we use that in combination for Nightwatch for doing our functional testing. We build using Docker. So I'm sure most people are aware now that Docker is a container-based technology that takes a lot of the pain out of virtualization. You can source control your Docker file, which defines the environment that your service is running in via something that's approximately like a bash script. We do all our builds on Jenkins. Now, I don't particularly like Jenkins. I find it a little bit slow and clunky. But the reason we use it is because it can do anything you want. It's a Swiss Army knife. So if what you're going to do is we use Ansible to do our deployment, it's easy from Jenkins to SSH to the deployment server to execute an Ansible playbook to download that Docker image and to push it. It's easy using Jenkins if we want to have some kind of cron job that's not based on the ticker. You can set up a job that just executes at 3 o'clock in the morning and runs. So that's the reason for Jenkins. I avoid anything like TeamCity because, not that they're bad products, but whatever clients I go to, if they've got TeamCity, it's always about 6 versions out of date and defunct. Whereas with Jenkins, because it's open source, you can update it yourself.
I have a couple of questions. I didn't know about Solar, so I looked it up on Google, and I found out it's very similar to Elasticsearch. So my question is, why didn't you choose Elasticsearch?
Yeah.
Because you could also use it for logging alongside Logstash and Kibana for monitoring.
Yeah. So another good question: why did we pick Solar when we actually are using Logstash and Kibana and Elasticsearch because of that, and unfortunately Zookeeper. So the reason why we use Solar, first of all, the search system for resources, they brought in a third party that was based on Solar, so it was there for that reason originally. Secondly, it proved to be incredibly reliable. So provided that you don't install it as a cloud, and that was unreliable when we tried it, and it constantly got out of sync with each other. But if you deploy it as master and slave, it's bulletproof. We haven't had a problem with it in 2 years. Response times for some fairly complicated searches are 20 milliseconds. So it's really, really, really impressive. The lesson for this is I would always use Solar again, to the point where we're actually starting to look at a product called Silk, which means that we can host Logstash and Kibana. We can integrate with Solar and ditch Elasticsearch, because Elasticsearch has been nothing but problems. It was the same for a long time at the Mail Online. The Mail Online is powered by Elasticsearch, and it's constantly getting itself into split brains. You've got to have Zookeeper, which is also pretty horrible deployed as well. So I would much prefer to go with Solar.
Okay, and how do you handle graceful degradation?
Graceful degradation of... okay. So I have a bit of a love-hate relationship with graceful degradation, because I kind of like to know when things go wrong. I appreciate users don't, but I do. And so a lot of that is done in the front end. So Page Composer gives us that to a certain degree, because if a part of the page which doesn't, that it's rendering isn't important, doesn't render, we just collapse it, or potentially we could serve in some Ajax-based snippet that attempted to go and fetch it again later. And Page Composer has been really, really good at that. It has a cache, and so you can say this fragment's lifetime should be 5 minutes, but it doesn't expire the cache. And so if you're within the cache time, it will use the cache version. If you're not, it will go and get a fresh copy. If the fresh copy fails, it will use the one that's stale from cache, but that's better than nothing.
And last question, how do you scale? Do you automatically scale, or do you have someone in place that scales the system?
So another good question, how do we scale? Well, for jobs, we don't have to. These services, their load average, they're 8 core boxes, and their load average is under 1. I think they're 16 gig. We're not using half of that. For the resources project, unfortunately, too many services that were nothing to do with resources got piled into that cluster of hosts, and they do have a scaling problem. And the reason is because of our overly simplistic deployment model. When we were building resources, we didn't want to go down this service discovery route, or this complicated route of saying, well, this service should have 3 instances, you can deploy it to 5 hosts. That stuff is quite complicated, and we had this resources platform to migrate. And so we're now at the peak on that platform for how many services can live on those hosts, and we don't want to vertically scale anymore. And because everything gets deployed to each host, adding another host doesn't really help. It's just as saturated as the others. And that's why we're now looking at these tools like Docker Swarm, so we can say, look, you've got 10 hosts, go and deploy to any 3 of them. But I suspect there's going to be some complexity in there, because what I've not come across, or when we were looking at this stuff a couple of years ago, it's not enough to say that your container has started to know that your service is ready for business. If you've got to go through and read config from etc.d and get a connection to Mongo and set up some Express listeners, it's only at that point when you can start receiving traffic. And so I know that you can do some of this stuff with console, where your service can say, yes, I'm available. But if you're running these things in Docker, well, it needs to know what public port it's running on. And so there's a degree of coordination. And 2 years ago, the tools really weren't ready for that. They might be now.
Thank you.
Hello. Are all the components in high availability?
Sorry?
Are all the components using high availability?
Are the components using high availability? I would say nearly high availability is a better description of it. RabbitMQ is highly available. What happens with Rabbit is that It will copy queues and it will copy messages between each node in the cluster if you've set it up to do that. It's an explicit option, you have to choose it. Mongo is running in a cluster and that's highly available. Solr is master-slave and so that's highly available. Each of our services are deployed to multiple hosts and are load balanced with Nginx. We tried using Elastic load balancers originally. That was a nightmare. It turns out with Elastic load balancers that AWS will redeploy them to different instances dynamically. And it does the right thing with DNS entries, but Nginx will cache DNS entries. And so what we found is that all of a sudden, AWS would redeploy a load balancer to a different host, and Nginx would be trying to connect to it on the old IP address. So we stopped using those, and that's when we did the Lua approach for Nginx to do the load balancing there. Where I think we have a bad approach to high availability is that when we deploy a service, we're not yet smart enough to drain the connections that service is processing. So we don't wait. We essentially, we kill a Docker service, we do them one by one, and so any in-flight connections being processed by that service get killed and then we restart it again. And so the end result of this is that, well, Page Composer protects us quite a bit, but as we do a deployment, there's a very, very brief fraction of time where most of our stuff is React, so it could just be an AJAX request that fails, and we'd redeploy 5 times a day. So given that a deployment takes very little time at all, and our load really isn't that high, 120,000 searches an hour across 6 instances of the service isn't really that many. The end result to the user across a lot of users isn't that significant, which is why we didn't put the time into working out how to drain the pools, but it's certainly an aspiration I have.
Hi again, another question. How do you store your Docker images? Do you have a private registry or
yeah,
build them on the host?
That's another good question. I don't know how much you know about the Docker registry that was provided. It was written, I think, in PHP and behind Unicorn. So we hosted that. You can get us a Docker image. We backed them on S3 because you want these images to persist if you have to redeploy that container. And we're still on the old version of that registry. And so it's our own private registry, but we're now having to update it because Docker have changed the protocol significantly. And from probably, I'm not sure, but imminently, we will not be able to upgrade our Docker daemons in order to talk to the old registry.
Yeah. Okay, thank you.
All right, so if you guys don't have any more questions, see how good are the questions we got for Spain? It's amazing. All right, guys, so we are heading the bar to have some beers. If you want to come with us, please follow Israel if he'll be on top waiting for us. And thanks a lot for attending the talk. Thanks.
Thank you.